Welcome back. In the previous video we have seen the testing of hypothesis for the large samples, small samples, test of significance for proportions when we have taken the proportions, single proportion by taking large samples where n is greater than or equal to 30. So the objective of this particular test is to test that the sample proportion is equal to the population proportion. That's why we have considered null hypothesis as small p is equals to uppercase P. Alternatively, small p is not equals to uppercase P, small p is greater than to P, small p is less than to P. For large samples, as if n is greater than or equal to 30, so we apply the Z statistics. So Z instead of means, here we have taken the proportions, power, especially the sample population proportion which is mentioned using the small p, where small p is equals to x by n. So x is will be the successes in the sample. So small p minus uppercase P divided by square root of p into 1 minus p by n. So where n will be the sample size and uppercase P will be the population proportion. So here we look at a particular example. So an auditor which claims that 10% of customer ledger accounts are carrying a mistakes of posting and balancing. So what is that claim? Null hypothesis stating the null hypothesis that the claim of the auditor is valid. That means there is no difference. So what is that? 10% of customer, 10% customers. Proportion. So proportion here we are considering. So how much? 10%. So small p will be 10%. And which is a negation of the null hypothesis is the alternative of p not equals to 0.10, which is considered as a two-tailed test, because here we have used equals to or not equals to. So small p x by n. So here 45 mistakes were found. So how many mistakes? Out of the 45 mistakes, out of 600 sample, 45 mistakes were found. So that is the proportion is 0.075. So as we are applying the Z statistics using the formula, we are substituting the values what we have from the problem statement, that is 0.075 minus proportion uppercase P, that is the this one uppercase P is 0.10, that is the 10%. So 10% what actually we are claiming. So by simplifying we are getting minus 2.049. So Z calculated value is greater than Z alpha, which is 1.96. So hence we say that null hypothesis is rejected. So in the same way, here there is a problem which is a directional hypothetical statement, so which is in the direction of left tail test. So same way here 200, see here what happened, an examination of sample 200 pieces of equipment revealed that 18 were faulty. So 18 were faulty, that means the total sample will be out of 200. If we remove the faulty, we get 95% of the as per the specification. So here that's why we are deducting. If you take directly 18 by 200, then it will be wrong. Why? Because he is here in this problem, it is stated that 95% of the equipments what he supplied meets the specification. So out of 200 sample, 18 were faulty. So the balance amount, the balance proportion actually which meets the specification. So what is that proportion? 0.91. So small p, where we have taken 0.91 and 95% as it is meeting with the standard. So by substituting the values in the test statistic Z, we get the minus 2.59. So Z calculated value is 2 which is greater than Z alpha at 5%, which is minus 1.6, hence null hypothesis is rejected. If in any case Z calculated value is greater than critical value, then we will reject the null hypothesis. So in the same way, when you have one sample proportion, and here in this case we have two sample proportions where P1 is equals to P2. So here again alternative hypothesis also, P1 not equal to P2, because proportion 1, proportion 2, proportion 1, proportion 2 we have considered. So Z test statistics is calculated as, so proportion 1 minus proportion 2. So P1 proportion 1 x1 by n1, proportion 2 x2 by n2. P, upper P here we call it as pooled proportion. So we are calculating the pooled proportion. How we are pooling? x1 plus x2 by n1 plus n2. So by taking up a problem, here we have a simple problem based on the two-tailed test. So simple random sample, 600 men taken from a big city. 400 are found to be smokers. In another out of 900, 450 are smokers. So out of 600, 400 are smokers. So P1 is equals to P2. That means we have to check whether in both the cities smokers are equal or not. So we are testing the proportion 1. Out of 600, 400 smokers, that is proportion 1 is 0.66, and proportion 2, out of 900 men, 450 are smokers, so 0.5. So pooled proportion P, capital P, is equals to x1 plus x2. So 400, 450 smokers, out of population 600 plus 900. So the pooled proportion will be 0.566. So applying the test statistics, that is Z, by substituting the values what we have, by simplifying, after simplification we get 6.459, which is greater than Z critical value at 5%. So null hypothesis is rejected. So in this way we calculate the test statistics. We test the samples when the proportions given where n is greater than 30. So in the same way we have seen hypothesis testing for large samples. When if we are taking for the small samples, the student t-test, which we use to determine whether there is a significant difference between the means of two groups or not. So there is no difference. There is a difference. Mu1 is equals to mu2. So small samples means less than 30. So here also, if mod t is greater than the t critical value, then we reject the null hypothesis. We reject the null hypothesis when mod of t table value, that calculated value is greater than the t critical value, then we reject the H naught. This we need to remember, because based on this only we will be writing our decision and interpretation also. So for testing the single population mean, the same way here, x mean minus mu by s by root n. So here s is nothing but the standard deviation. That's why here we have used x minus x mean whole square, summation of x minus x mean whole square. This is nothing but the standard deviation what we are trying to find, and which is denoted as s. So s is an unbiased estimation of unknown population standard deviation. So with the t distribution, and here when we are taking the t distribution table also, we have to look at the n minus 1 degree of freedom. Say for example, if n number of sample size is 10, 10 minus 1 will be 9. So we have to look at the degree of freedom at 9 table value when we are looking at the table. So here there is a sample problem. So the average breaking strength of the steel rod is specified to be 18.5 thousand kg. For this, a sample of 14 rods were tested. So the mean and standard deviation obtained were 17.85 and 1.95 respectively. So here when we are looking at the null hypothesis, so there is no significant deviation in the breaking the strength of the rods. So that means, so it is equals to 18.5 is specified to be 18.5. So here also we are specifying it should be 18.5. So alternative hypothesis will be it is not 18.5. So 210 test. So how many rods are there? So number of rods will be 14 and x 17.85. The mean and standard D obtained were. So mean is 17.85 and the standard deviation is 1.955 and degree of freedom. So n minus 1, that will be 13. So how many rods are there? 14 rods are there. So n minus 1 will be 13 and alpha will be 5%. Level of significance will be considered as 5%. So applying the t statistics formula, especially for single mean, this is for single population mean. So we get negative minus 1.2543. So from the t table, so this is also one way of writing interpretation. See, minus 2 point, see we don't know. See, sometimes we may mention two tail test or one tail test. Suppose if I want to mention two tail test means, so here I am taking the plus or minus value. So when I am taking the plus minus 2.1 left side, this is the left tail value and this is the right tail value. So our calculated value is this one. So minus 2.160, which is less than this, and minus 1.243 is less than 2.1. So hence H naught is accepted. In the same way, left tail test. So here we have a directional hypothetical statement greater than 20,000 and less than 20,000, and we got positive here 1.6, but still it is less than 1.753. So table calculated value this one and critical value is this one, and hence H naught is accepted. Here if we observe, there is a so here in this particular problem, though it is a two-tail test, here he has not given the deviations, actually variance, standard deviation. So if you observe what he has given, n is given, degree of freedom is there, alpha is there, standard deviation is not there, mean is not there. So we have to calculate the mean as well as the standard deviation. So variables What are the variables that were obtained? 11, 14. So here variables we have taken. So we are I have calculated the mean because mean is not available. So we have to calculate the mean, and I am checking the deviation, that is x. Suppose if I consider this variable as x, so d will be deviation, d will be x minus 12.5. How I got 12.5? So summation of the values divided by number of observations equals to 12.5. So this 12.5 I am considering as mean, x minus x mean. D square, so deviation square, d square is nothing but the deviation square. So what I am doing, I am squaring the values what I got here, minus 1.5 into minus 1.5, so I have 2.25. So summation of this column will be 10.5. So here the t statistics, x mean minus mu. X mean how much we got? 12.5, and total population is 12. So S value, so 10.5 is the summation value here, 10.5, and 10 minus 1. So number of observation is 10, 10 minus 1 is 9. So root of that 1.20. So simplifying by substituting all the values, we get 1.319. So which is less than 2.262. Hence H0 is accepted. So here there is another problem. Here in this problem, 12 patients in the increase of the blood pressures. See, if we observe here 5 to 8 minus 1 3, the stimulus will be in the gen. See here also mean is not given, standard deviation is not given. So deviations we need to find. So here variation, suppose considering this variation, whatever it is given in the problem, chronologically or orderly, with the highest negative value to the highest positive value in an order. We have considered the data, and how many times. See here, if we observe minus 2, we have only one patient, whereas 0 0 we have two patients. So here I have 0, so I have how many patients? 2 patients. That means 2 times 2 patients are there with the 0. So assumed mean x minus a. So assumed mean, how I have taken? So mean is equal assumed mean, assuming mean as one particular value. This I have assumed mean as a 2. So a plus 1 by n summation of d. So 2 plus 1 by 2 into 7. So that will be 2.58. So x mean I have considered as 2.58. So d is equals to x minus assumed mean. So x is how much? Minus 2. Minus 2 minus 2. How much? Minus 4. In the same way, minus 1 minus 2 minus 3. So 0 minus 2 we have minus 2, because assumed mean as 2. So you have to write a note in the examination also, which assuming mean you are considering. And now multiplying the deviations with the number of patients. So frequencies, this is a frequency, how many times, how many members are there. So f into d, minus 4 into 1, minus 4 into 1. So d is minus 4, f is 1. So minus 4 into 1 is a minus 4. 1 into minus 3, minus 3. 2 into minus 2, we have minus 4. Squaring the d values. That means this value. These values has to be squared. So minus 4 into minus 4, 16. Minus 3 into minus 3, we have 9. Now it has to be multiplied with the f into d square. F into d square. So f into d square already we have. Now f into d square. So 1 into 16. So 1 into 9 we have 9. So 2 into 4 we have 8. You know, this resembles the calculation of the standard deviation only what we have used, because here we don't have mean as well as the standard deviation. So we are trying to find out the mean as well as the standard deviation. That's why this particular formula we have used, and we have also used this formula in the calculation of the standard deviation. So the same formula will be applied here also to calculate the standard deviation, that is summation of fd square by n summation fd by n whole square. So inserting all the values, whatever the calculated values, we get 2.892, and hence as 2.8 greater than, so hence H naught is rejected. So when hypothesis testing, two population means independent samples. See, independent samples, again here we have when the variances are equal and when the variances are not equal. So here also if we observe this one, x1, it is we are calculating the variance here. So S square. So S square standard deviation square is the variance actually. So we will be calculating the variance. So x1 mean minus x2 mean by S square into 1 by n. That's why S square is called as a pooled variance. Pooled variance of what? Pooled variance of two population means. What is the two population means? Population mean 1, population mean 2. So that's why we have sample means S1 and x2, and we have sample sizes n1 and n2. So here we will be taking the degree of freedom n1 plus n2 minus 2. So n1 is how much? What is the sample size here for the population 1, population 2, sample size whatever it is there we take. And when variances are unequal, we say this t-test is also called the Wells t-test. So here it is also simply S1 square and S2 square, x mean, x2 mean, two proportions, again two proportions. But when it comes to the degree of freedom, so we need to apply this formula to calculate the degree of freedom only when we are using this particular method, that is t-test, Wells t-test, when unequal variances are there. If there is a difference, if there is a lot of difference in the variances, then we use that particular t-test. So let us have an example here. So we have two groups of students, first group and the second group, and the marks obtained are there. So here what we are taking, there is no significant difference. So that is no significance difference. There is a significant difference, not equal. So S square, basically here also calculation of the standard deviation and variances. So sample variances we have to calculate. So x1 minus x1 mean whole square. So here how I have taken that x1. So x2, x1 minus x1 mean. So summation of x1 by number of observations, you will get the x1 mean, and in the same way x2, summation of x2 by number of observations you will get. So here what I am doing, I am deducting the mean value from the x1, that is 18 minus 37 we have minus 19, 20 minus 37 we have minus 17. In the same way 29 minus 34 we have minus 5. So after finding x2 mean minus x2 mean, squaring the values, so x1 minus x1 mean whole square. So we need to get the data for this particular calculation. So that means this particular value is required. What is that? Summation of x1 minus x1 mean whole square. In the same way as we have two populations, summation of x2 minus x2 mean whole square. So degree of freedom, this is the degree of the free, n1 plus n2 minus 2. Simplifying, you substituting all the values whatever we have calculated in the formula T statistics. So we have 0.571 and degree of freedom, n1 is how much? 9, n2 is 7 minus 2, so 14. So we have to look at the calculated value at the 5% level of significance using the degree of freedom 14. So critical value is equals to 2.145. So hence the null hypothesis H naught is accepted. So like that we have another problem. So paired t-test. So this is another important, especially two populations are taken and small samples, n is less than 30. So here t statistics will be calculated as d mean by standard deviation by root n, where d mean is x1 minus x2 I. Again here if we observe the variance, this is the standard deviation calculation is there, degree of freedom will be n minus 1. So by taking a sample problem, so this is the sample problem where he has given the scores before, after training, before training, after training, score before training, score after training. So I am considering this one as x1 and after as x2. So deviation x1 minus 75 minus 70, 70 minus 77 we have minus 7. Now di minus d mean. So this is the summation is minus 45. So minus 45 by 9 number of observations, you will get minus 5. So di minus d mean, that is 5. So you have minus 7, minus 11, 8, minus 2, 0, minus 1, 5. There is some mistake in this problem. Okay, anyhow, if I go through di minus d mean whole square, x1 minus d is equal to x1 minus x2. So this will be the di minus d mean. So here actually you have to consider mean, that is 5 minus 5 minus minus 5. 5 minus so plus 5 will be there. Okay, so there is small. We will look at some other problem. So